So far, we've used derivatives to locate local maxima and minima of a function. Basically, we've used it to locate the peaks and the valleys in the graph. Sometimes we're not only interested in locating these peaks and valleys, but we're also interested in determining which is the highest peak or the lowest valley. In this case, we're interested in determining what's called the absolute maximum and minimum of the function. So a point a comma f of a is an absolute maximum point of a function on an interval if the y-coordinate there is bigger than or equal to every other y-coordinate for all x in the interval. If you remember, for a local maximum point, it only needs to be bigger than or equal to the y-coordinates on either side. Here it has to be bigger than or equal to every other y-coordinate. The value f of a is called the absolute maximum value. The absolute maximum point is the x-coordinate and the y-coordinate. The absolute maximum value is just the y-coordinate. A point a comma f of a is the absolute minimum point of a function f of x on an interval I if the y-coordinate there is less than or equal to every other y-coordinate for all x in the interval. The value f of a is called the absolute minimum value. Again, the absolute minimum point is an x-coordinate and a y-coordinate. The absolute minimum value is just the y-coordinate. In examples 1 and 2 here, we're going to locate absolute maximum and minimum points of each graph using the graphs themselves. So, in this first graph here, we're basically going to look for the absolute maximum point and the absolute minimum point. That means the highest possible y-coordinate and the lowest possible y-coordinate, which means the highest and lowest points in the graph. Well, the highest point is up here. That's going to be the absolute maximum point. The lowest point is down here, which is going to be the absolute minimum point. So we say the absolute maximum point is about 2.5 comma 4.5, and the absolute minimum point is about 1.5 comma negative 0.5. In the second graph, the absolute maximum point occurs up here and the absolute minimum point occurs down here. This is the highest point of the graph, this is the lowest point of the graph. So here the absolute maximum is at 5 comma 6.5, sorry, 6.5, and the absolute minimum point is at negative 2 comma negative 11. Note that these points are the endpoints of the graph in question, which means they are not local maxima and minima. To be a local maximum or a local minimum, you've got to be above or below the points on either side. This point doesn't have points on the right-hand side, so it cannot be a local max. This point doesn't have points on the left-hand side, so it cannot be a local min. It turns out it's possible to be the absolute maximum without being a local maximum, or the absolute minimum without being a local minimum.